Hello, sorry about that. All right, hello prob stats and welcome to 9.4. This one here's about standard deviation in two populations again. Again, we'll be using about the same thing we've done before, except now it's called an F test because it's actually named after a guy. I'll make you got stat disc going and let's go. Okay, we'll do a formal hypothesis test on the claim about two population standard deviation is what we are looking at. It's not writing well. There we go. In this section, it's called an F test for testing this claim. It's actually named after Sir Ronald Fisher, and it is very sensitive to departures, so normal distribution is critical. When you go through, we have a few more things to look at. S sub 1 squared is your sample variance. It is always the larger, so the larger is always your 1, and the smaller will always be your 2, so make sure you realize that. The one with the sample variance that is larger is S1. Okay, so that goes the same for the N1 and standard deviation and the variance. All right, let's go down here. Our requirements. They have to be independent. They have to be a simple random sample. They have to be normally distributed. This is very, very important and is very strict. So independent, random, normal. Again, we do have a formula we can use. Now, when we look at this here, I just want to talk about this a little bit. The F is equal to 1 when these two are very close. Now, remember, the one that is on top is always the larger of the two. All right, it can never be the smaller. The S1 is the larger of the two sample variances. All right, so when you're looking at your stuff, make sure you put S1 as the largest so you get the right data. Okay, p-values and critical values will also be by stat disc. We will always be looking at the right tail test. Because we're letting S1 be the larger one, it's always going to be at the right tail. That's why that's so important. We never have to worry about the left tail. So don't forget, S1 is the larger. All right, the F distribution. We have two normally distributed populations. It can be the variance. Remember, if we take the square root, that's the same thing as our standard deviation. And our test statistic is calculated here, but we'll be using stat disc. Again, it is not symmetric, all right, because now it is a skewed right, just like before, nothing different. Let's get back to where we were. Okay, when we look at this, if it is close to 1, okay, when the ratio of these two is close to 1, have equal variances, all right, so we can't get rid of it. When it is not close to 1, all right, then we can reject. All right, so a large value of F will evidence of these here two against this, that we will reject this if that is true. All right, here we go. We're going to use stat disc. Okay, course evaluations. We got male and female. I know we've typed this in once before, so you have it. It's great. If not, you need to pause and type those in now. All right, we're going to look at the two samples. Populations are from populations with the same mean. We're going to use the data of 0.05, and we're going to look for the variation between these things. So we got to check our requirements. First one, are they independent? And yes, male and female have nothing to do with each other. Okay, the two samples, are they completely random samples? When we type them in, they both pass the Reiner-Joyner. So yes, they are random samples. Okay, and simple random samples. I said that wrong. They pass normal because of the Reiner-Joyner. So they pass all three. Our requirements are good. We're happy. So now we're going to put these into stat disc. You're going to look at your descriptive statistics, and you're going to look at your standard deviation, and the female is 0.563, and the male is 0.3945. All right, so now to do this, we're going to claim that they're equal. So we can either use the variances or the standard deviations. I will almost always use the standard deviations because there's no reason to complicate our calculations further by squares. We don't need to do that. The opposite of this is the original claim is false, so they are not equal. So now we have our null hypothesis, which is they are equal, and our alternative, which is they are not. We have a confidence interval of 0.05. Because we're talking about two population variances, we have to use the F test, named after Sir Richard. pressure. All right. So we are in stat disk now. You're on hypothesis testing. We are doing the standard deviation between two samples. Okay, we have alternative hypothesis. They are not equal. We have our significance level. There were 12 from the first. You typed in your standard deviation of 0.563. There were 15 in the second with a standard deviation of 0.3945. Now you are looking at your statistics over here. Okay, we're going to look at our test statistic of 2.20691. Now let's look at our lower and our upper. So our lower is here, right here, and our upper is here. Now we look where the 2.0269 falls, and it is in the middle, so we fail to reject, right? It is not in our rejection region. Now let's look at our p-value method. 0.2138, again, is greater than 0.05. Again, too large, we fail to reject. All right, so since it is not in the critical region and we fail to reject, we've got the same thing both times. We cannot reject the null. Okay, there's not sufficient evidence to warrant rejection claim that the two standard deviations are equal. So then our course evaluation scores of female and male professors appear to have the same amount of variation. We cannot verify that for sure, but we can say it appears so. We do not have sufficient evidence. Okay, pause and do yours. Make sure you go through your requirements. I know that you will not be able to know if they are all of them met, but assume they are. But make sure you go through what the three are. So pause and do your work. I understand the requirements are a little bit harder this time, but I hope you at least went through what the three had to be. They were independent, check. They didn't have anything to do with each other. They were random, so we're assuming they picked random ones, check. And we have to assume normal distribution because there's no way for it to check what the amount they gave us. All right, our first one is we want to assume that the standard deviations are the same. So the opposite is they are not equal, which makes our null. The standard deviation 1 equals standard deviation 2, and the alternative is they are not equal. We had a significance level of 0.05. Since we're doing two populations and standard deviation is an F test. Now, when you did your stat disk, you should have gotten, this here part has to do with critical value, 2.4, the lower of 0.28 and the upper 3.14. So here is your rejection region over here and here. The 2.41 does not fall in there, so we fail to reject. That's with your critical test. The p-value, 0.12, is greater than 0.05. Again, we fail to reject. Of course, they should have given us the exact same answer, which they did. All right, so we failed to reject the null. There's not sufficient evidence to support the claim that the two populations have different variances. That is all we can say. Not a whole lot to that one, huh? All right, good luck on your homework. I hope you do well. Make sure you're using StatDisk and looking for which one is largest so you get the correct S1. Okay, good luck and post questions if you have any.